Good morning. Welcome to another session on environmental impact assessment.
So we shall continue with Unit 3, Air Quality, Noise, Energy, Water Quality, Vegetation and Wildlife Impact. Course outcome: apply the knowledge of impact of infrastructure projects on air quality, water quality, vegetation and wildlife. Learning outcome: environmental impact assessment for air pollution. Specific outcome: step-by-step procedure to be adopted for conducting EIA for air pollution. So in the last few sessions we have seen definition of air pollution, the sources of air pollution, the classification of air pollution, and the types of air pollutants, right? So in this session we'll be looking at the step-by-step procedure of conducting an EIA for air pollution. So step 1: evaluation and identification of sources, types and quantities of pollutants generated by different phases of a project activity. Step 2: detailed evaluation of existing ambient air quality, meteorological conditions and natural air quality existing in the project area. Step 3: examination of appropriate laws, regulations, and criteria to be implemented statutorily for maintaining the ambient air quality. Step 4: carrying out impact assessment of project activities using mass balance, mathematical methods, or qualification prediction. Step 5: assessment of significance of anticipated beneficial and detrimental impacts. And the last step is appropriate mitigation or remedial plans for reducing the adverse impacts. So these are the 6 steps that are involved, and we'll be looking at each step in detail. So step 1 is evaluation and identification of sources, types and quantities of pollutants generated by different phases of the project activity. So in the first step, one has to examine what types of air pollutants are likely to be emitted during the construction and or operational phases of the proposed project activity and their quantities. So from unit 1 onwards, I hope you remember that I have been telling that it is not only the pollutants that are being emitted during the operation of the plant or industry or factory. We need to evaluate the impacts on the environment from the pre-construction phase, construction phase, operational phase, maintenance phase, decommissioning phase. So in each of these phases, pollutants are being released, right? Or there is an impact on the environment. So here what we have to do is we have to find out the air pollutants that are being released in each of the different phases, the quantities that are being released. An emission factor is the average rate at which the pollutant is released into the atmosphere as a result of some activity such as combustion or industrial production divided by the level of that activity. Since it is a factor, you have a numerator as well as a denominator. Um, Emission factors relate to the types and qualities of pollutants emitted to indicators such as production capacity, qualification of fuel burnt, or vehicle miles traveled by an automobile. So air pollution sources of is so uh, here what uh, is being shown is some of the pollutants that are being released for some activities like solid waste disposal. So solid waste disposal, what they do is they dump the waste on open lands and they burn it, right? So what are the sources of air pollution here? The pollution is caused due to refuse incineration. Incineration is type of burning. Then there is open burning, sewage sludge incineration. So sometimes what happens is that you get some sewage sludge, meaning the solid matter that is being left behind after the dewatering process of the sewage, right? So effluent treatment plants will generally have a lot of sewage, and what they do is they will remove the water from that and the solid material is burnt. So that is sewage sludge incineration. Combustion activity: coal combustion as fuel oil combustion, natural gas combustion, wood waste combustion, right, in boiling, and lignite carbon, right? So combustion activities lead to a lot of air pollution. Industrial mineral products production like coal cleaning, sand and gravel process, stone carrying process, and chemical industrial processes such as boiler coal burning, chemical reactor gaseous effluents, wastewater treatment plants, acidification and neutralization reactions, solvent evaporation, right? And solvent evaporation specifically in reaction processes. So movement of the pollutants. So a three-part process describes the mechanism by which the use of motor vehicles affect the lives of human beings through the air. So the three-step process are emission, dispersion, and reception. So emission is releasing of the air pollutants into the air. Dispersion is they travel in the air, and reception is it is being received by human beings, plants, animals, and so on. So this is a three-step process by which the air pollutants travel from one location to another location. Step 2, detailed evaluation of existing ambient air quality, meteorological conditions, and natural air quality existing in a project area. So ambient air quality means the air quality which is at present in the atmosphere wherever you are located. So that is the ambient air quality. Key meteorological data. So what we need to do here is categorization of meteorological parameters which hinder dispersion of pollutants emitted into the atmosphere uh, have to be made based on the following criteria. 1. Meteorological data which describe the general air pollution dispersion characteristics of the study area. Meteorological data useful to describe the atmospheric dispersion of air pollutants from a project activity quantitatively. Third, meteorological data useful and necessary for air pollution dispersion modeling. Step 3, examination of appropriate air quality emission regulation laws and air quality standards to be maintained as per local, state, and central government notifications. So the basic information of air quality standards, criteria, and policies of local, state, and central government agencies which have the statutory authority to maintain the air resources have to be collected. So what are the air quality standards? What are the policies that are to be followed with respect to air maintaining the air quality standards from the local bodies, from the state government, central government agencies? All these things have to be collected. Documentation of this information will allow the determination of the significance of air quality impacts incurred during projects or activities and will aid in deciding between alternative actions or in assessing the need for mitigation measures for a given alternative. Step 4, carrying out impact assessment using mass balance uh, methods or mathematical modeling or a single qualitative approach. So there are basically three aspects of air quality problems that are amenable to quantitative prediction in the order of increasing complexity. Sorry, it's a continuous sentence. In the order of increasing complexity, they are: first one, estimating the rate of release of pollutants; second one, predicting atmospheric concentration of pollutants; third one, predicting disposition rates of pollutants on soil, water, and vegetation. So first one is the rate of release. Second one, predicting the concentration of pollutants in the atmosphere. Third one is the deposition rate of these pollutants on you know, some things like soil, water, vegetation. So impact prediction can be carried out using various approaches like mass balances, ambient air dispersion models, and plume dispersion models. These are some methods to actually, predict how the pollutant will be traveling into the atmosphere, right? So if you understand this much, it is sufficient for this course, because if I go into detail, I need to explain each one of those things in detail, which may not be necessary for you, right? So the areas likely to recover impacts of various pollutants from the various project activity sources should be assessed. Prediction of concentration and deposition rates are often needed as inputs into other predictive models to determine the potential for secondary and higher order impacts. So we need these concentrations and deposition rates for predicting the potential of these pollutants on uh, these pollutants in the future, right? We need to find out the secondary and higher order impacts. So for that we need this data. Step 5, assessment of significance of the impacts. And the last step is development of appropriate mitigation or remediation plans for reducing the adverse impacts. So remediation or mitigation measures for reducing the adverse impacts involve project activities, design or operational features that can be used to minimize the magnitude of air quality impacts. Mainly, the design should be revised as needed in order to reduce the air pollutants expected to be emitted from the project activity. The revised project or activity can then be reassessed to determine whether other remediation or mitigation measures will help in eliminating or minimizing the deleterious air quality impacts. So here what they are saying is that we need to come up with some mitigation plans so as to reduce the impact on the environment, right? So we need to maybe revise the design in order to reduce the pollutants that are being emitted from the particular activity. So we end the session here. Thank you.
Thus, we come to the end of this session. Thank you for your participation. Looking forward to meeting you in the next session.